Example 1.4.1. A particle of weight 5 newtons is in equilibrium on a rough plane inclined at an angle of 60 degrees to the horizontal. Find the normal reaction and find the friction force acting on the particle. So let's start with a good diagram. Here's my inclined plane, and then a particle. Doesn't matter what it looks like, I always just tend to draw a box to represent it. So sitting on the rough plane, if it's a rough plane there will be friction. So if it says smooth, then there'll be no friction. If it's rough, there will be friction. The plane is inclined at 60 degrees to the horizontal. The plane is the surface it's sitting on. So a plane is a two-dimensional surface. We need to find the normal reaction and the friction force acting on the particle. So let's put the forces on. The weight, which will always be vertical, and we've been given the weight here, so that is 5, not 5g. If we were given the mass as 5 kilograms, then the weight would be 5g. But in this case, we've been given the weight directly, so that's just 5. The normal reaction, normal meaning at right angles to the surface. And then friction. We need to know which direction friction will be acting. Well, think about if this was a smooth plane, if it was a smooth surface, which way would the particle slide? Obviously, it would slide down the slope. So therefore, friction, which always acts in the opposite sense to motion, will be acting up the slope. Friction tries to stop things moving. So if friction wasn't there, it would definitely slide down the slope. There's nothing to make it magically move up the slope. For that reason, friction must be acting up the slope. So we're going to resolve in two directions. Resolving is the same as doing Newton's second law. I'm going to start by resolving perpendicular to the slope. Tell the examiner what you're doing. N2 stands for Newton's second law. This little arrow with a right angle means I'm working perpendicular to the slope. So we have R already pointing in my direction, and then it's going to be minus 5 cos of this angle here, which will be 60 degrees. So we have a right angle there with the weight being vertical, which makes this angle 30. So the force of 5 newtons needs turning through an angle of 60 degrees. So it's cos of the angle you need to turn it through. And that's the F in F equals ma. Because the particle is in equilibrium, that means there is no resultant force in any direction, which therefore means there's no acceleration in any direction either. So the right hand side there is mass times acceleration, but because the acceleration is 0, the right hand side is going to be 0. So R will equal 5 cos 60, and cos 60 is a half, so R is 2.5 newtons. So that is the normal reaction force. I'm now going to resolve parallel to the slope, and I'm going to resolve up the slope. It's your choice whether you choose to go up or down the slope. Because we're trying to find friction, that's why I've chosen up the slope. So then friction will be positive in my equation, and then I've got less rearranging to do. So friction pointing up the slope, but then the 5 force needs turning through an angle of 30 degrees to point in the direction I'm working in, but it'll point the wrong way, which is why I need a minus. So it's always cos of the angle between the force and the direction you're currently working in, so it'll be 5 cos 30 degrees. If you wrote sine 60 instead of cos 30, that's absolutely fine, that is still correct. Same as earlier when we were finding the reaction force. If you wrote sine 30 where I wrote cos 60, they are the same number, so they are both correct. This will equal 0, because as we had before, there's no resultant force in any direction, therefore there's no acceleration in any direction either. So friction turns out to be 5 cos 30 degrees, and cos 30 is root 3 over 2. So we can leave this as an exact number because g was not part of our calculation. No rounded numbers were used in calculating the friction, so we can give an exact answer.